Hey everybody, today we are going to continue the lesson from Trigonometry number 4, and we're going to get into what happens when the law of cosines gets a little bit weird. Yesterday we did 4 examples, and we talked about how the law of cosines is a very ugly looking formula that turns out to be pretty easy to use, because you can type it in the calculator all at once and you don't have to worry about anything else. Now, today we are going to do a couple problems where you have to do some extra work before you type it in the calculator. Okay, so that's going to be a little bit frustrating, but we're going to get through them. We're going to do a couple examples of it, and then you'll sort of practice yesterday's and today's on your own. We'll have a few problems for you to try and do on your own. So let's get started here. I think right now, right away, you notice as you go through this next problem, you notice it's going to be different than the others. And the reason that you know it's going to be different is they gave you no angles and 3 sides. Now, that's not really that big of a deal. I mean, if you remember back in the day, side, side, side was a perfectly good way of knowing the 2 triangles were going to be congruent. You know, we've done this type of problem before where you're dealing with 3 sides. But the idea of having to solve for each angle is pretty crazy. Now, let's think back to what the law of cosines looks like. And it doesn't matter which one of these we do first, because the law of cosines gives you the freedom to use any of the 3. So let's just take the initial formula that we learned yesterday. A squared equals b squared plus c squared minus 2bc cosine of A. Now, we were given 3 different versions of the law of cosines. That was just the first version. Okay. Now, if we were to plug in everything that we know into the formula, then it would look something like this. 39 squared equals 14 squared plus 27 squared minus 2 times 14 times 27 times the cosine of A. Now, the reason I told you this example is going to be more annoying than the others is because we don't actually know the angle. And since we don't know the angle, we can't just type in the entire right side on the calculator because we don't know everything on the right side. So we're going to have to do this step by step. Okay. All right, so we're probably going to need to know what that is, and what that is, and what that is. And then we're also going to need to know what this is. I'm trying to get all the calculations out of the way so you can see where we're going here. All right. So let's throw this into the formula, see what this ends up looking like. We get 1521 equals 196 plus 729 minus 756 cosine of A. Now, this is the part that people get wrong the most. There's always a temptation to try to do 196 plus 729 minus 756. Guess what? This is not a like term with the other 2. So this is locked in to place. That's the worst lock in the history of mankind. All right, there you go. this part is locked into place because it has a cosine of A on it. So all you can really do is 196 plus 729. That's the only part that you can do right now. Okay. The other one has cosine of A attached to it, so you're not allowed to touch it. So you're going to get 1521 equals 925 minus 756 cosine of A. At this point, you subtract the 925 from both sides. And if it seems like this problem is a bigger pain in the butt than yesterday's was, you are exactly right. That's why I saved it for a new day. 596 equals negative 756 cosine of A. Now we divide both sides. And then we are going to, from there, use the inverse cosine. Now, this is going to bring up something that you might not have ever seen before. Why is this thing negative? Does that mean we did something wrong? Turns out, no. Whenever you're dealing with cosine and your angle is obtuse, cosine is actually going to be negative. So when you're doing the inverse cosine, and you're doing the inverse cosine of a negative number, it means your angle is going to be obtuse, and that is okay. So we're going to do inverse cosine of the answer. All right, there you go. And that number is going to go right there. And angle A is 142.03 degrees. Okay. So hopefully you can see why this was different than the other one. You had to do a lot of steps before you used the calculator. You couldn't just throw it all in the calculator as it was. Okay. Now, once we get here, this is where we're going to do the familiar part. I told you yesterday, and it still holds true, you are never going to use the law of cosines more than once in any given problem. At this point, now you can use the law of sines. So that's what we're going to do. And we are going to say sine of 142.03 over 39 equals the sine of b over 14. Cross multiply like we normally do, and we're going to get 14 times the sine of 142.03 equals, boy, I am going to run out of room here, that's all right. I warned you, I told you this problem was going to be a little bit ugly. That's all right. We'll make it. We're almost done, actually. Once you get here, divide both sides by 39. 14 times the sine of, I don't want to round, so I'm going to type in A and S for answer, divided by 39. Okay. There you go, perfect. Then we're going to do the inverse sine of the answer. We are so close. That is a tiny angle compared to what we've been doing. It actually makes quite a bit of sense if you think about it. Angle A was so obtuse that it didn't really leave a ton of degrees left for the other two. It sort of took almost all of the 180 for itself. Okay, so we'll do that number plus 142.03, and then we'll take however many is left from 180, and that will be my third angle. 25.21 degrees. Now, usually whenever you're doing a trig test or a trig quiz or whatever, I usually only do maybe one of those problems. Certainly no more than two, because there's just so much going on, and I understand that it's a long problem. Okay. So, pause this if you need to. We're going to do one last problem together. And this one, I think, has potential to not be too bad for a number of reasons. Hopefully, you notice a little bit about what will make this last problem just a little bit more pleasant than the others, okay? A equals 7, B equals 7, C equals 10. So why is that going to be better? That's not a 10. All right. Well, we've talked about how if you have two of the same side, then you're going to have two of the same angle. So what that really tells me is we don't have to do that much work here. All we have to do is the law of cosines one time. Because if we do it one time and we get one of the angles, the other two will take care of themselves. Okay, so it doesn't actually matter which one we solve for. Whenever we do the law of cosines, it doesn't really matter. So we can just do A again. It doesn't make any difference to me. So that's what we'll do. We'll just say A squared equals B squared plus C squared minus 2BC cosine of A. Now, you know there's another part about this problem that I like. We don't need the calculator to set it up. Because we know all these numbers. All right, so 49 equals, remember what I talked about before, it was super cheesy, but that's okay. This is locked down. You can't touch that part because it is not going to be a like term with the other stuff. Okay, so you can add the 49 and the 100 over here, but you can't do anything with the other stuff. 2 times 7 is 14. 14 times 10 is 140. So I'm just telling you right now because this is what kids mess up the most. I have seen some of the smartest kids you have ever met try to do 149 minus 140. You can't. This is locked down. They are not like terms, so don't do that. What you have to do instead is subtract 149 from both sides. So whether you like it or not, you have to do it this way. If you try to combine like terms when you can't, you will get the problem wrong. I'm not telling you to be annoying, even though I'm really good at it. I'm telling you because I've seen it over and over and over again. I've been teaching this about as long as you've been alive. All right, so what we have to do instead is subtract from both sides, then divide, and then do the inverse cosine. So that's what we're going to do. Notice that we're going to have a negative divided by a negative. Okay, we'll leave that number in the calculator. That's actually, it actually just reduces to 5/7, so I didn't really need a calculator, but that's okay. And then remember, whenever this happens, we can do the inverse cosine. All right, so let's do it. Inverse cosine of the answer. 44.42 degrees. Now, I told you this one was going to be better. Let's talk about it real quick. Why would this problem be better? Well, A and B are the same length, which means big A and big B are also going to be the same. They have to be. Isosceles triangles have two of the same angle. They also have two of the same side. All right. Now what that means is I can just add it to itself and then take that away from 180. And you get 91.17 degrees. Now, if you're wondering, technically these three add up to 180.01. That's totally okay. What happened was, when you round to the nearest hundredth on all three of these, you end up getting these numbers, and rounding does technically create a very, very small error. So if you're looking at this and you're like, well, how in the world does this come out this way if they don't actually add up to 180? Well, they do add up to 180. There was just a little rounding error here. So anyway, so hopefully number 6 made a little more sense than number 5, because we were a little better at it and we didn't have quite as much to do on that problem. I do thank you for watching. Hopefully this gives you a jump start on the rest of the work. You have a few problems to do on your own today. In the meantime, take care of yourself, take care of each other, and I will see you next time.